And welcome back, and it is the 4th of April, further maths 5 a day, and let's just jump straight in. Give that, I think it means given that, but given that this equation here, find the values of A, B, C and D. Right, I'm going to zoom in just so I can explain it slightly better. So what we've got is we've got an identity. So in other words, when I put any value of x into here, it must be the same as any value of x over here. So it's not an equation where I rearrange and solve, it is a do something with the thing on the right and then compare terms. So let's deal with the right hand side. So I'm going to keep it zoomed in so you can see what I'm doing. So therefore my right hand side, RSS, right hand side, is going to be, now I'm just going to expand this so you can double check it, you can sort of go away. Basically I've done Pascal's triangle so many times, I know what this is going to be. So it's going to be A times x cubed minus 3x squared plus 3x minus 1. And then it's plus, well actually the rest of them are just written out, aren't they? So then it's plus 2x cubed plus bx squared plus cx plus d. So let's actually try and combine these terms. So the x cubed is going to be, well, the a from here and the 2 from here. So it's going to be a plus 2. The x squared is going to be minus 3 from here and b from here. In other words, b minus 3. The x is going to be, well, 3a from here and... Actually, sorry, I just realised I missed the a. Let's go back. Let's do this properly. So b minus 3a. So the x is going to be 3a minus the c from here, plus the c, that should be. And the constant, so I'm going to put x to the 0, which just means constant, is going to be minus a plus d, which I'm going to write down as d minus a. Now, as I said, it must be the case. The only way this is going to work is if the values are the same values, in other words, the coefficients. Now this is clever because I've just realised we're missing one, aren't we? In other words, x cubed is going to be 6, because it's this 6 here. X squared is going to be minus 5. There is no x, so therefore that's 0. And then d minus a is going to be equal to the constant, which is equal to 10. In other words, 4 unknowns, 4 equations, I can definitely solve this. Let's start with the x cubed. The x cubed, so that a plus 2 equals 6, which means that a is equal to 4. Then I'm going to put that into the b. So this is the same as b minus 3 times 4 is 12. It's minus 5. So add 12 to both sides and b is equal to 7. And then the x value, so again, I know it's 4. So 3 times 4 is 12. So 12 plus something is 0, which means the c must be minus 12. And then finally down here, d minus a is 10. I know a is 4. So therefore, well, let's actually write this one out as well. So d minus 4 is 10, which means that d is going to be equal to 14. What a good question. That's sort of like a mid-paper, pretty difficult, but not terrible question. I like that question. Next one. Right, what do we have? So a straight line has equation. The point that has the coordinates this lies on the line calculate q. Okay. I like this question. This is one of these questions where if I told it to a year 7, they'd probably know what to do. But because you know too much maths, you sort of think it's harder than it is. It's not actually harder at all. I'm just going to put my q into here. I'm going to put my y into here. One equation, one unknown, solve the equation, get my q. So let's do that. So I've got 8 times q, x value, minus 5 times q plus 1, y value, plus 25 equals 0. Let's do some collecting. So 8q minus 5q is 3q. Minus 5 plus 25 is plus 20. Is equal to 0, which means that q equals minus 20 divided by 3. And that's it. That's my answer. Not too bad, that one. Right. We haven't seen one in a while, have we? And I cannot see a quick way of doing this, but I always miss them anyway, but that's fine. Let's just concentrate on the z, shall we? So let's label them first. So 1, 2, 3. And I'm going to do equation 2 minus equation 1. So 3x minus 2x is x. 2y minus 3y is minus y, and z minus z goes away or cancels, and 40 minus 41 is minus 1. Let's call that equation A. Then, what am I going to do? So equation 1 times 3. So 3 times equation 1 is 6x plus 9y plus 3. Z equals 3 times 40 is 120 plus 3, so 123. And I'm just going to write equation 3 underneath, which is going to be x plus 2y plus 3z is equal to 44. Now, just to explain what I am doing, I'm basically using simultaneous equations to get rid of the z's. I'm eliminating the z's, which leaves me with just two variables, and then I can use normal simultaneous equations to get the variables, put them back in, find out what the z values are. So in other words, if I do minus here, that's going to tell me that 5x plus 7y equals, well, 123 minus 44 is going to give me 79, yeah, 79. And that means I have two equations. So I've got equation A and equation B. And it's just a standard GCSE simultaneous equation now. So let's do equation B. So equation B is 5x plus 7y equals 79. And then I've got 5 times equation A, which is going to give me 5x minus 5y equals minus 5. And then I'm just going to take these things away because the 5x's cancel, don't they? So I've got 7 minus minus 5 is 12y. And 79 minus minus 5 is 84. And this does indeed work out nicely to give me y equals 7. And let's go back to equation A. So x minus 7 equals minus 1, which means that x is equal to 6. So I've got my x, I've got my y, and then equation 1, all the way back at the start, 2x, so that's 2 times 6, plus 3 times y, which is 7, is plus z is equal to 41. Well, 2 times 6 is 12, and 3 times 7 is 21, and 12 plus 21 is 33. So that means 33 plus z is equal to 41. So z is equal to 8. And that's it. That's my answers. Good sort of fine. I haven't seen one of those in a while. So actually, I didn't mind that too much. Really good mix of questions again today. Really like that first question. A very good first question. And a nice middle question, because very easy just to go the wrong way and just do the wrong thing. So well done if you got that one. And as ever, do let me know how you did. Like, subscribe. See you tomorrow. Thanks all.